All right, so now we're going to talk a little bit more about unpremultiplying and premultiplication. Like I said, this is usually where people learning get a little bit tripped up. So we're going to cover this kind of in a visual theory way. And if you're still confused, don't get overwhelmed. You know, we're going to jump into Nuke, and once we start actually doing it and going through the motions, it'll probably make more sense to you. So this is kind of the theory, and hopefully it'll break down as to why we're doing things. But if you don't fully grasp it right away, don't worry about it. It's not abnormal, but once we get into it, I think it'll make a lot more sense. So, yeah, it's a very important concept. So we have the red, green, and blue channels versus the alpha channel. So you'll hear me talk about this a lot, and it's really important and keying to understand how to separate the image and recombine it as necessary. So we'll talk a little bit more about it. So premultiplication, you know, as we kind of already know, we've already kind of looked at this, taking an image, multiplying it by the black and white alpha that we've created, gives us a final result. So it knows how to merge it over a background. So one being solid and black being fully transparent. So this is a quick review as well. So these are three examples of if you merge an image over a background without with different scenarios. So the first one in the top right here, we have no alpha. So you can see it looks like a plus operation. So what that means is it's just the colors are being added and they're not being merged as an over. So basically what that means is if you look at the top right, it doesn't look right. Things are transparent, and that's because there's no alpha in the picture. So you're trying to merge an image over another one with no alpha. Second one is giving the image an alpha. So it has the proper alpha with the green screen removed, but there's no pre-multiplication. So you see there's still a green kind of haze around the guy. So we're looking at the second picture on the right there. And that's because, yeah, so there's an alpha, but it's not cutting away the parts that need to go away, basically. And then finally, we have an alpha that's been created and then pre-multiplying the image and then merging it. So the last one is the correct result. So the main rule with this is do not color correct on pre-multiplied images. So if we've already applied that alpha cutout and we've pre-multiplied it, so we've combined those two images, we don't want to apply color corrections after that operation has been performed. And so this is usually where people get a little bit tripped up and not understanding why. And so I'm going to try to explain and break down the reason that is. So most color corrections, as we've learned, are dependent on the brightness of an image. So if we color correct after we pre-multiply, Nuke will mistakenly treat your semi-transparent edges as if they are darker. So a semi-transparent edge is not a darker color. It's only more see-through. That's how you have to really start to think about this. So the next slide will actually explain it better. But just looking at this histogram on the right here, we know at the top there it's affecting the highlights more, and we know the middle is affecting the midtones more. So if we look at a picture, it's going to make a little bit more sense what I just said. So this is a normal node graph, and we can see at the top right picture there, there's no dark edge or anything like that. We see the color around the color wheel fades off, and it's a fine result. But the second one here that we have is you can see this kind of dark halo appearing around the edges, and this is because we have a color correction after the pre-multiply. So the reason this is happening, it's not that we can't apply color corrections to an image going over. The reason we're getting that dark halo, I'll explain in just a second here. So why is this dark halo happening? So Nuke is looking only, when you're doing a color correction in Nuke, it's not, usually the color correction is being done on the red, green, and blue layers, okay? Or the channels, rather. So it's only seeing that image. It's not even really paying attention to your alpha. So if we're looking at this circle and we zoom it up really big, so we can see this red, we're looking at that little color wheel, and we can see, we zoom into this red portion here. What we've done is made this color wheel a bit blurred on the edge. But, so I'm going to read the quote on the bottom here. It says, these two reds are exactly the same amount of red. One is more transparent, but nuke thinks is fading into black because we've already pre-multiplied it and we're applying color correction. So if we look at the very dark edge of the red, the second arrow here on the right, it's a darker red if we're looking just at a screen. But we know that that's actually the same exact red as the other arrow is showing in the center. So these two reds are exactly the same. It's just that one is more see-through. And nuke doesn't understand that's more see-through. It sees it as a darker red. Okay, so that's basically the premise, is that blurred edges, semi-transparent areas, they're being treated as darker colors potentially. And that's not how we want to treat the colors. We want to treat those two reds in this example as the exact same color. So what we do, so if we do a gamma down, which we know gamma affects more in the darker colors and the midtones. So nuke is affecting the darker regions more than the brighter regions. But again, in this case, that red is supposed to be exactly the same. It's not supposed to be a darker red on the edge. It's more see-through. So before we pre-multiply, like for example, if we want to feather and make that soft edge on this color wheel picture, we want to do the color corrections there. We don't want to have those semi-transparent areas being color corrected differently. And that's in essence what causes this problem. So here we have a sharp edge. There's pure color. There's no transparency baked in. So if we color correct this image, it's not going to darken the edges differently than the center colors. So if I play this little video here, we can see if I'm applying a gamma, nothing is happening there. So we can see it's kind of darkening it. Let me just rewind here. So you see it darkens it. It's kind of adjusting that color wheel. Stuff's getting pushed around there. And the alpha is still that sharp alpha. So it hasn't, it doesn't have a soft edge. So if we create a new alpha for it and we erode in the alpha. So if I look at the alpha channel and I make a softer alpha, I switch that to a Gaussian blur, so it's kind of filtering a soft edge. So maybe that's what we want. We want a soft object or whatever. So now we have the alpha. And now if we do the pre-multiply, we have the color wheel there with the color correction applied to it. And you see that there's no dark halos appearing around this color wheel. It's because we did the color correction before the pre-multiply. So if this color correction was placed after, we would have a dark edge. So this is a bad node graph. The top left image here, we see pre-multiplying grade. If we want to do the same exact correction, but we just want to do it the correct way, we can see below under the ideal, we have an image, a grade, and then a pre-multiply. And there's another picture to the right of that. I don't have a cursor on this app here, but the image to the right is showing another possibility next to the ideal. We can unpremultiply, place a grade, and then re-premultiply. So obviously this is kind of redundant in this example. You're saying, well, why would I unpremult, do a grade? And in this situation, it's redundant, so it's not really the best way. But it's just so you know that you could do that. And later on, when your keys get more complicated, you'll understand maybe why you would want to unpremultiply. So we're going to get into more advanced examples later. And hopefully that will clear it up. But this is kind of the main principle of premultiplication. And if you're still confused, don't get too worried. We're going to go through actual examples, and you're going to start to understand as you do it. But hopefully this starts to clarify it a little bit for you. And yeah, that's